So this here is an example of airflow and how you get the velocity of airflow with a pitot-static tube. Okay, so we have the tube in here. Okay, I can move it in and out of this chamber right here. Basically, this is a Venturi tube. This used to be an experiment where you would see how the air velocity changes along a constantly increasing diameter. We're going to put the probe at the point of the lowest diameter, okay, which is actually the point of the maximum velocity, just so that you can see the greatest difference in pressure, okay? The pressure on these scales are read in inches of water, okay? So it's sort of similar to inches of mercury, I guess, but yeah. So I'll turn this on right here. Okay, and it's interesting to see how the static pressure has a negative value, okay? Now, static pressure, as you know, the cross-section of the hole for the static pressure probe point is perpendicular to the flow, okay? So, basically in airflow, that static pressure is below your atmospheric pressure value, okay? Realistically, you never really have a negative value of pressure. Pressure could only get to 0, okay? But since we're comparing this to your atmospheric pressure, it is below your atmospheric pressure. Now, your total is still positive, so that is greater than atmospheric pressure. So it's important to realize when you subtract the two, you have P total minus P static, you're actually subtracting a negative. So it's basically you're adding the absolute value of both of these numbers for this case. So again, you have your dynamic pressure is total pressure minus static pressure. Static pressure is negative, so you have a positive minus a negative, which is positive plus positive sign convention.